I just finished building this little model tugboat, and I've got a few projects planned for it, but I thought it might be a good idea to give it a test run before I spend a few months building an engine for it, and then it all sinks to the bottom of the pond or something. Well, I've got a few of these spare motors from my old quadcopter, and I think it'll work, but this thing's going to be a little too fast. This motor will turn about 25,000 RPM. It's a little fast for a tugboat. So I think we need some sort of gearbox or something. And here's what I came up with. It's a peanut-shaped box with a fistful of gears in it. And it's got a 2-to-1 ratio on the first stage and a 2-to-1 ratio on the second stage. That'll give us 4-to-1 in total. And with any luck, that'll get the propeller down below light speed, hopefully a little more appropriate for a tugboat. Maybe the world's fastest tugboat will have to be one of the future projects we do. Well, gears are fun to make, why don't we start with them? I'm using this piece of bearing bronze I had left over. This will be the bigger gear for the first stage. Now the output shaft is pretty much the same as the gear we just made, and you've got to set it up in here. Hey, are you paying attention? Hey. Quit daydreaming. Here it is off the milling machine. We're going to use our old friend the superglue arbor to hold it for the second side. Now this guy gets a bearing pressed into him to hold the back side of the input shaft. Or is the back side of the input shaft holding the front side of the output shaft? And that wraps up both of the larger gears. Let's go ahead and make the small ones. These ones are a 12L14 free machining steel. And there you have it. one idler shaft. Now the input shaft's pretty much the same, so I just went ahead and made them real quick. It's basically the same part, just a bit longer. Well, that's all the gears made. I don't know what it is about gears, but they're so satisfying. They're fun to play with. These bronze ones sure turned out pretty, didn't they? Well, anyway, let's go ahead and make the case now. This guy's just a block of aluminum. I squared it up off camera and put these two spots in it. These are right on the center distance of the gears. So we'll go ahead and use those to set it up in the lathe. And that makes it real easy to put the bearing bores right where we need them. Now we're going to need to drill and tap all the mounting holes for the cover real quick so we can hold it for the next operation. Now I'm going to show you a super top secret method for tapping small holes. You'll never believe this works. See? Told you wouldn't believe it. So I went ahead and made up this little fixture here. It fits right down in there on the bearing bore. But we can screw it down, and that way we got something to hold on to so we can stick it back in the milling machine. Now we need a little teeny tiny end mill to sneak through the space between where the bosses for the bearings are. And you're probably thinking to yourself, well, Jellyfish, I bet those little tiny end mills are real easy to break. And you'd be right. There's a reason I buy these 5 at a time. So that's the first half done. Now we just take the fixture out, stick it on the other side, do it all again. Wouldn't be a jellyfish video without a bunch of super fast filing, would it? Oh man, look at him go. There's the gear case, just about finished off. Now we still got a few parts to make, but I don't know about you, I want to press some bearings into this thing and stick the gears in there and watch them all go around. Well, we got to assemble the idler shaft too. This guy's just press fit together. Neat. At first I was going to make an aluminum cover for it. But man, I don't know if I can cover up those gears. They look really nice. So I think we'll make one out of acrylic instead. Yep, that turned out nice. Let's go ahead and press some bearings into that guy. Well, we need a few pulleys real quick. Let's go ahead and make those. Yep, those look like pulleys. Now the output gear gets this little stub shaft for a prop shaft coupler to fit onto. I'm just going to hold him in the Loctite. Oh, yep. It's a little harder to turn with grease in there. I made up a couple of mounting plates for it. This one holds the motor on. And this one will hold it into the boat. For the drive belt, I'm just using an off-the-shelf O-ring. Well, that's the whole gearbox assembly. Let's go ahead and stick it in the boat. Here's where that coupling I told you about fits on. Just a little dog bone coupling that I bought online. Well, looks like it's working. Let's go ahead and throw some electronics in there and head out to the pond. Well, it's a boat. It's doing boat things. That's a good sign. Suppose it's better than if it was doing airplane things. Well, it sure got plenty of power. I think that was only about half throttle. Well, I wanted to get some more clips of it running, but then this happened. Listen close. Uh-oh. That's not good. Yep, something seized up, dead solid. Well, that was an awful lot of work for 5 minutes worth of boating. Let's see if we can figure out what happened. No, the input shaft looks okay. Idler cluster seems fine. I think it might be... Oh, yeah. I guess I made the clearance a little too tight there. Looks like it was running on the aluminum housing instead of the ball bearing. Yeah, looks pretty ugly in there. Well, anyway, it did its job. The boat didn't sink. It seemed to run okay. So I guess it means I can move forward with some of the projects I've got planned for it. But I'm not sure. Wonder how many cylinders it should have. Thanks for watching.